Alright guys, I'm going to walk you through the rest of this PowerPoint from Tuesday. So today we're just going to cover more slope-intercept form, plus point-slope form, and standard form. This was our warm-up from yesterday. If you don't already have these in your notes, be sure to get these in your notes. Our slope-intercept form of the line equation, our standard form of the line equation, and our point-slope form of the line equation. I mean, I'm going to be honest, I don't ever want to look at this problem again, but that's not the answer. We just found the point-slope form here. So on this slide, actually, I do want you to take note of something interesting that we did find out. Just as how you can reduce fractions by dividing, you can also expand them or increase the numerator and denominator by multiplying. So if you run into some little nasty like a 5.5 in your denominator, you want to multiply that by 2 or 3 or 4, depending on whatever you need to multiply it by to get a whole number. That's how we found that 3 over 5 1/2 is equivalent to 6 over 11. I mean, this problem was just traumatizing. We needed to get into this form, and honestly, I would accept this, but you can't have fractions. And thus I made this quiz a bonus quiz, but it is still an important skill to have, so that's why we're going to go through this video review of everything that we couldn't cover yesterday because of that evil problem that literally took up the entire class period. All right, so there's a really important concept on this slide that we did not talk about in class. Now, where did my pointer go? There she is. And that is, how do we handle a flat line? Flat line. Well, Stickman, if he be walking, he'd be really happy because he is walking just on a flat sidewalk. When we have a flat line, our slope is 0. Okay, so our slope for this equation would be 0, flat line. All right, now let's write this line equation. I see a y-intercept. See where I'm crossing the y line? So I want to use my slope-intercept form. It's not telling me what form to use, so I'm going to choose, and I'm going to choose slope-intercept. Y equals mx plus b. All right, well, we already found our m, which is 0, so let's see what happens when we plug that in. Y equals 0x plus b. What does that guy mean right there? That means we have no x's. X times 0, or anything times 0, is 0. So this would then become y equals b. Let's find our b. We need to replace b with a number. It's -3. This one would simply just be y equals -3. Because for any given value of x, our y will always be 3. What does that mean? Well, that means that at -4, y is 3. At -3, y is still 3. At +4, y is 3. At +5, y is 3. At positive 567 for x, way over here by my head, y is still going to be 3. All right, now this one we see here is a much like the crazy one that we did in class. This is saying use point-slope form to write an equation of a line in standard form. Okay, so it's telling us to use that point-slope form. We can't use slope-intercept because look at that. We don't have a defined, easy-to-find y-intercept. So we do need to use that point-slope form again. So first thing is we need to gather I need to pull up my digital pen. There we go. We need to gather our points. There's one at -3, 2, and then our other point is at 2, 1. Okay, and then we need to decide which one of these are we going to use in our equation. Okay, now we usually go for the easiest, which this one would be easiest. But in this case, we're going to go with the one with the negative because we need more practice with doing that. We need more practice with understanding that we have a minus sign inside of our point slope form, which means that these points are the opposite of what we see. All right, that means that if I see a -3 over here, I am going to make this a +3 at the end. Why? Let's find out. So this is going to be my group 1. These are the ones I'm going to use. Okay, so the point I'm going to use is -3, 2 for my x1, y1. Okay, we got 1 done. Now let's find the slope. What is our slope? Well, it's our rise over run. So let's figure out what that is. So I need to first run down to there. Run, -1. My run will be, or my rise, excuse me, my rise, crazy lady. My rise is -1 because I dived down 1. So my rise is -1, and then now what is my run? Well, I go 1, 2, 3, 4, 5. My run will be +5. Let's check to make sure we're correct. Stickman, he'd be walking downhill. That means negative slope. Our slope is -1/5. Now let's plug in all this information we just found. So I have my y minus my y1, which is 2, equals m, which is -1/5, times x minus my x1, which is -3. I do still need to clean that up, but I can clean that up in the next step. So this double negative here, and so let me get my pointer back out. Laser pointer. This double negative right here. Anytime we subtract by a negative, it is the same thing as adding a positive. So I am going to turn that into x plus 3. That's why we think in terms of opposites. So now I have y minus 2 equals -1/5 x plus 3. Next step is to distribute our 1/5 into our parentheses. So this will give me -1. Oh, here, let me show you what I did. So I multiplied 1/5 by x and 1/5 by 3. So this will give me -1/5 x plus, if I go 1 times 3, or -1 times 3 is -3 over 5 times invisible 1 is 5. And then on this side, I just bring down all that junk I haven't used yet. Now this is looking a little more like something like that terrifying problem that we did in the first place. All right, so really what we got to do here is we got to marry together our 2 with our -3/5, and we got to get, so that 2 needs to get over there, and this needs to get over here with our y. So first things first, let me move my 1/5 x term. I'm going to do that by adding 1/5 x to both sides. All right, now for my next step, I'm going to come up here. Let me just scribble, scrabble. There we go. Now I'm going to write my x term first because it comes first in my standard form. 1/5 x plus y minus 2 equals -3/5. Okay, now one more step to get into the basics of the format we're looking for, all right? The next step is I need to add 2 to both sides. So that cancels on this side. Now we have 1/5 x plus y equals, and then we need to look at this mess here. -3/5 plus 2. -3/5 plus 2. We'll throw that over a 1. We need to make these have the same denominator so we can combine them. And I do that by multiplying the top and bottom of my 2 over 1 by 5, which will give us ultimately 10 over 5. If I multiply my 2 by 5, I get 10. 1 by 5, I get 5. And now I can see that I have 10, 9, 8, 7, 7/5 left over at the end. All right, so this will be 1/5 x plus y equals 7/5. Now, for me, that's an acceptable answer. Let me clean up that 5 there real quick. Eraser. Let me rewrite that 5 so it doesn't look all 6-y. That should be a 5, not a 6. There we go. Now, acceptable for me. This looks like standard form to me. But OLMS wants you to get rid of these fractions. And we need to do that by multiplying everything by 5. Okay? Everything on this side gets multiplied by 5, and everything on this side gets multiplied by 5. We can do it if we're doing the same thing to both sides. All right, so first we got to distribute this in like so. So this 5 cancels that 5 out to leave x by itself, and then 5 times y is 5y. Set that equal to, if we multiply these together, cancel, cancel, 7 by itself, 7. And that is the completed equation. All right, let's do it one more time, but this time we're going to go a little bit faster, so rewind this if you need to, okay? Now, this is telling us to use point slope form. Whoop, why aren't you writing point slope form to write a line in slope intercept form? So at least this time we're not having to write this in standard form again. All right, so first things first, I need to choose. Am I going to go, which one of these points am I going to go with? And I'm going to choose that one. So in my point slope form, my x1 comma y1 will be -1 comma 2. I got to really watch out for that when I input my x1. Now for the slope, let's calculate our slope. We have our rise over our run. All right, so let me see first what my rise is. Now, Stickman, he be walking way downhill, so it's definitely going to be a negative slope. And we're going to see that by diving for our first, for our rise. So I need to go to that red point that I just made. I have 1, 2, 3, 4, 5, 6. -6 for our rise. -6. Now our run, how do we get over to that 1, -4? We run to the right, 1, 2, that would be a +2, which would mean that our slope is -6/2. But that's totally reducible. 6 divided by 2 is 3. Negative divided by a positive is a negative. So our slope here is -3. Okay? Now, life hack. Do you see the y-intercept? We could totally jump at this point into y equals mx plus b form, but that wouldn't be following the directions. So we are going to do it correctly, but we could use that little y-intercept to check our answer at the end. Okay, so now I got to plug in my slope and my y1 and my x1 into my point slope form. So I have y minus y1, which is 2, equals m slope, which is -3, times x minus x1, which is -1, which is going to turn into a +1. All right, that was a minus -1 in there, if you're wondering what just happened. So then from there, we need to distribute our -3. Distribute. So I'm going to first start off, bring down the junk I haven't used yet. All right, and then I got -3 times x is -3x. -3 times +1 is -3, or we can turn that into a -3. Now, this one's nice because this one only has one step left. All we need to do is get this 2 over there with its cousin, the 3. It's a -2, so I'm going to do that by adding 2 to both sides. So that cancels out to 0, and then I come over here and I add 2 here. -3 plus 2, that's a different sign subtract. I find the difference of the 2, and I take the sign of the larger. In this case, it'll be 3, so this will become -1. Bring down everything we haven't used yet. Y equals -3x minus 1. We have arrived at slope-intercept form, and we can check our answer right here. Look at that. Could have just jumped to it from the beginning. All right, guys, home stretch here. We are to write the equation of the line in slope-intercept form. Yay, another slope-intercept form. We do need to get happy when we don't see standard form up there. So first things first, let's look at this graph. You may be thinking, but wait, Miss Hill, the ordered pairs aren't listed. But you know what? That does not matter. We can go in here and we can pick out our ordered pairs. And I see some really nice easy ordered pairs lying at our y-intercept, which is at 0, 5, and our x-intercept down here at -2, 0. Nice points. Let's look at these two in reference to which one we're going to choose in our formula. Now, like I've said before, when we're dealing with positive, it does make things easier. Now, you could choose the 2, 0, but I'm going to go with 0, 5 this time for my y1, x1. So my y1, x1 ordered pair, I'm going to use 0, 5. All right, step 2, we got to find that slope. We got to find that m, so we got to figure out that rise over that run. So I'm going to start way down here at my x-intercept point, 2, 0, and I'm going to calculate my rise, which is going to take us up to there, and then my run over to that other spot. So my rise is 1, 2, 3, 4, 5. That's a +5, I swear. It's a little slop fest, but that's okay. And then my run is 1, 2, +2. And then we'll confirm that in just a second. So my rise over my run, 5/2. Beautiful. And we can confirm that we're supposed to be positive. Let's get our stickman down there. Stickman, he be walking uphill. Uphill is a positive slope. So now we have all the information we need to plug this into our point slope form and then turn it into slope intercept form. Now, a little hint, pro tip here, we could have gone straight into slope intercept form, but we're not going to do that because we're practicing converting these forms. All right, so I'm going to start off with my y minus y1 equals mx minus x1, rewriting my formula, rewriting my form so it can help me memorize it. And then I'm going to plug in my numbers. So I have y minus y1, which is 5, equals m, which is 5 halves, times x, which is 0, minus, crazy teacher. Hold on, back it up. I put that 0 in the wrong place. That should be my regular x. Sorry, x minus x1, which is 0. Nothing, nada, zilch. Then we're going to come down here and do some simplifying. So the nice thing is when we distribute into that 0, it becomes 0. So we can just call this 5/2x on that side. Boom, done. Nothing else to do there. Then on this side, we still have y minus 5. We need to deal with that 5. We need to kick it over to the other side. So what am I going to do? I'm going to add 5 to both sides. Minus 5 plus 5 is 0, cancels out. And then I add a 5 over here. Let's rewrite it so it's looking pretty and make sure we are in the right format. So I'm going to go all the way up here to where I see my format written. And I'm left with y equals 5 halves x plus 5. That is our final answer. And can we confirm it? Yes, we can. Let me get my laser pointer out here really quick. I really wish my pointer came up that well on Neuro. All right, so here we see our b. Our b is +5, which means that the point it's at should be 0, 5, which was the point we chose. And is that a y-intercept? Yes, it is, because look, that's where we're crossing the y-axis. So we totally did this one correct.